Okay, so in this video, I'm going to start talking about binary search trees. So let's get started. Okay, so what is a binary search tree? It's pretty similar to the linked list in that it's a collection of nodes. The biggest difference, though, is that the nodes have two pointers instead of one. Here we have a left pointer and a right pointer. And in the linked list node, we had only one pointer that was pointing to left. Remember, we had something like this. We had some sort of numeric value. Value goes here. Here we had next, and then that points to the next node, right? In the binary search tree, we have two pointers, one that points to the left and one point that points to the right. And just like the linked list where we had a pointer to point to the first node, it was called head on the linked list. Here it's called root, and it points to the first node. And if you notice here in this diagram, what I did was I put the address, the memory address, here in the pointer, right? So root is pointing to address 200. So here's address 200, and then address 200 contains a node, and that node, it contains two other pointers, one pointing to the left at address 250, which is right here, and then it also contains a pointer pointing to the right it's pointing to the address 325, so that's pointing right here. And then the same thing happens for the other nodes, right? So this node here left is pointing to address 192. And the thing with these addresses are I just made them up, right? They're random. The compiler or C++, that's usually how it allocates memory. It just kind of puts it where it fits or where it's available. So I did kind of the same thing here. So there's really no pattern to these addresses. It's just a way for us to refer to the nodes, and we'll use these addresses later on. But just keep in mind that these addresses, you don't actually input them yourself directly, right? And then some of these nodes have an address of 000. Use this number to represent null. Right, so in other words, this node with the value f has a left child but no right child. That's what these are called at the lower levels. Right, this is the parent node, and then the parent has two children. Its two children are f and r. And then this child has its own child with value b. That's kind of like real life. This is your dad here, right? And then his children are, let's say, this person here and this person. But then this child has its own children, and then these are the grandchildren of dad. You can think of it that way. At the very bottom of the binary search tree, we have the nodes, and they don't point to anything anymore because this is the end of the tree, right? So here, if they're at the bottom and the addresses here are null, then we called these nodes at the very bottom, all of these, we call them leaf nodes. Leaf. The other very important thing to notice about the tree is that the values to the left are going to be less than the values to the right. These are greater here. So we start with M, but then F is less than M because F comes before M in the alphabet. But yet here we have the letter R. R comes after M, so then R goes to the right. Right, and the same thing for P. P comes after M in the alphabet, and so does S. So all those are on the right side. And anything that is less than M goes to the left side. Here, this is called the left subtree. And then here, this is the right subtree. Right, so anything in the right subtree is going to be greater than the parent node, and anything to the left is going to be less than the parent node. And then you can kind of see that pattern here as well. In this subtree, we have the parent node R, and then the child node here, P. P comes before R, so it goes to the left, but yet S comes after R in the alphabet, so it goes to the right. Okay, so now let's take a look at how to actually implement one of these in C++. Okay, so first of all, since we're going to be working with strings in this example, make sure you include the string library. Okay. Now let's develop a class, and we'll call it binary search tree. Okay, so for our private accessibility section here, we'll need to first write the struct for the node. Right, so let's do struct. I guess we can call it tree node. And our node is going to consist of some sort of value. It's going to be of type string. So string, we'll call it value. And then the nodes are different than the linked list nodes because they have 2 pointers instead of 1. So this one will be a tree node pointer. We'll call it left, and then we'll have another tree node pointer, and we'll call it right. Okay, and then our constructor for our node is going to be called tree node. It's going to take a value. It's going to take the tree node pointer called left, a default parameter of null, and then one more for the right. I'll zoom out a little bit. We'll initialize our instance variables here. So this value here is going to be, we're going to assign the value from the parameter here. And then we'll do the same thing for left. and then we'll do the same thing for right. Also here for private, we will need the pointer for the root node. So that'll also be a tree node pointer, and we'll call it root. Okay, so once we've set up the code for our node, the next thing we need to work on is actually inserting values. And the way we're going to do this is we're going to use two functions. Right, we're going to have a private function. We're going to make it the return type void. It's going to be insert. And then I'll come back and we'll set up the parameters here in a little bit. Well, at least we know for sure insert is going to need to take some sort of value. So it's going to be string value. And then we're going to have a public section in our class. And here we're also going to have another function with the same name. We're going to overload the function. The way we're going to overload is that we're going to have to put an extra parameter here, but I'll go over that in a little bit. But just for now, set it up this way. Okay, so how do we actually insert nodes into our tree? Right, so our tree starts off like this. We just have the root. This is null. There's nothing there. So I'll put the slash through it like last time. So this means that the tree is empty, right? So let's say I want to insert the letter M. Right. So if the tree is empty, then we just create a new node. And so let me create the new node here. Right, and it's not pointing to anything because there's nothing else to point to, so that's null. That's null as well. And then here we have the M. But then here, this is now going to point down here. Fix that a little bit. So that's our first condition when the tree is empty. All right, so let's code that. Okay, so we have two insert functions. The actual implementation of inserting the nodes into the tree is going to be done by the private function. So we're going to do most of our code here. So the first condition was if the tree is empty, right? Then we need to insert the node and reassign the address of the root from null to the new node, right? So that means that we need a reference to this variable here. So let's do that. So tree Oh, I think I have my insert key on. Sorry about that. Well, that's fine. Just retype it. So tree node, and then we need a reference to the pointer here. So this is going to be a pointer, and then to pass by reference we need the ampersand. And rather than calling it root, we'll go ahead and call it tree instead, right? Because you can't have the tree without the root, right? So we'll do it this way. Yeah, and then I'm going to take the space out of here. And then we need our value that we're going to insert into the tree. So string, or into the node, sorry. Value. Okay, so if the tree is empty, then we need to create a new node. So new tree node. And remember that our constructor for our tree node has, oh, this is supposed to be string, sorry. Okay. It has a default parameter of null for left and right, right? And since this is the first node, there is no left and right, so we'll go ahead and rely on these default values here, default parameters, so that we'll pass just value. And then we'll assign the address of the new node to the tree here. So tree is now the new tree node. But keep in mind, we only want this code to run if the tree is empty. All right, so how do we know if the tree is empty? If tree is null. All right, so that means that this pointer has no address, so that means there's nothing in the tree, so then we'll just go ahead and create a new node. And then we'll return at this point. Right, because we're going to have other if statements as we start inserting new nodes based on different conditions. So once this condition is met, then this function no longer needs to run. Right, but this method here, or this function, is private. Right, so that means that we'll need to access this function from this public function here. Right, so here we will also pass the value, the string value, but this will return, or not going to return anything because it's void. It's going to call insert and it's going to call this insert instead. So then it's going to use root and value. And the reason it's done this way is that we don't want the user in main to have direct access to root. Root is protected because it's private here, right? So rather than having the user somehow get access to this pointer and have to reference it and also pass a value, what we can do instead, doing it this way, is we can create our tree, a binary search tree, we'll call it just tree, and they can access only this insert function here, and that way they don't have direct access to root. So they would do tree dot insert, and they only have access to the one that takes one parameter, right? So then the user calls this insert function, which is this one here, which in turn will call the private function, which is this one here. Okay, so the next condition is what if the value is already in the tree? Do we want to insert the node again? No, there's really no point. So we need to check for that. So if the value, this one here, is equal to tree value, right? So if the value is the same as the value being passed to the parameter, then we just return, right? We don't want to insert it, so this will take us out of this function. Okay, so the next condition is what if we already have a node in our tree? So let's say I want to insert, the letter F. Okay, so then what's going to happen here? First, it's going to check if it's empty. It's not empty, so it's not going to do that. Next, it's going to check if the value here is the same as this one. It's not. So then now we need to decide where is it going to go. Since F comes before M in the alphabet, and if you remember that the values that are less than the parent node, they have to go to the left side, right? So since F is less than M, then it needs to go here. So let's erase this. So then our new node will go right here. So that's F. And this guy are null. Now his left is no longer null, and he has a new value. Insert it there. Okay, so let's say I need to insert R. So we go here from root. Root is null, not null. There is no R already in our tree. So then, since R comes after R is greater than M, then we need to go to the right. Oops. Okay, so then the new node will be created. That's R. And then we'll send it to the right. Okay, so I kind of went back, I cleaned up my example a little bit. So this is what we have currently. Right, we have our tree with M, F, and R. And here I assign some addresses to the pointers here. And we can also say that when the user calls insert B, or insert and then he passes some sort of value, that in reality it calls the private function. This is the private one here, private. and it took two arguments. It took the root and it took the value, right? So here I put, instead of putting the variable name, I put just an actual address itself. So root is address 200, and it's passing the value b, right? But we also assigned the parameter value we called tree. We called it, we pointed to the same address, so we can say that tree and root are the same, right? So that's why I wrote tree here on this side. So then our base case, so yes, we're going to have to use recursion to actually insert a node that's insert a node into a tree that's already filled with nodes, right? So I'm going to insert b200. It checks the base case. Since this address is not null, right? It's got m, it's got this, it's got that, so it's got values in it. So if that's the case, then it needs to see if the new letter that's being inserted, if it's greater than or less than the current value it has, right? So in this case, b is less than m, so then it's going to have to go to the left. So that means it's going to have to call insert again recursively, but this time it's going to call insert and it has to call 150. So 150. And it's going to pass the value of b. But rather than, since we're not actually working with actual addresses in the code, the way we would reference the next node is by writing insert tree, and then we go left, and then we pass the value, whatever it is, right? This tree left is the same thing as 150 because there's a node at 150 that's left of m, right? So since this is recursive, it's going to have to check the base case again, right? So at 150, is 150 null? No, it's got a value in it. Okay, so since this is a recursive call, then we need to check and see, now that we're at this node, b is less than f, right? So we're going to have to go left again. We're going to have to go this way. So then we're going to recursively call insert, but we're going to have to call it again on tree left. Tree left at this node is 0, 0, 0, which is null. And then we pass the value, right? Okay, so then at this point here, we call the function again, and then we look at the base case. If tree, and trees, this is just a pointer that keeps changing, so it keeps changing tree left, tree left. So now at this point, tree on this insert equals 0, 0, 0, right? So is 0, 0, 0 equal to null? Yes. So then now we can insert the new node. We create the new node here. Right. We use the default parameters to set left and right to null. And then the address here, which was tree left, which is this guy, now is pointing to B. And then here, there's actually something in it now. So then now this is 150. Okay, so let's see the actual code for this. Okay, so for the code, the diagram might actually be more complicated, but the actual code is pretty intuitive. All right, so if the value, which is this here, if the value is less than tree value, right? So whatever is in that node, whatever its value is, so if it's M and we're trying to insert a B, or we're trying to insert an F, we know that that's less than what's already there. If that's the case, then here's where we do our recursion. We insert, and then we have to go a certain direction. First we started from root, but if the value in that root node is less than the value we're trying to insert, then we need to go left. And then of course it needs to know what to insert into the node itself. So that's value. Right, so we go left here. Else we have to go to the right. So we can put a comment here. If the value being inserted is less than the value of the current node, then we got to move to the left. If the value is greater, then go right. So then this is going to be called recursively until we meet one of our base cases. These two guys here are our base case. So this is base case 1, base case 1. If the address is null, and this is base case 2 if the value is already in the tree. Yeah, so these two base cases will stop our function from calling itself over and over and over. Otherwise, we'd have an infinite recursive call, right? So either one of these cases needs to be met. If neither of them is met, then we need to go either left or right. Also, be careful not to make this mistake here. I did tree equals null. I meant equals null. Okay, I think everything else looks pretty good. Okay, so now that we have our insert function set up, now let's work on actually displaying the values in the tree. Okay, so let's set up our public and private function to display the nodes, the values in the nodes, and we're going to display them in order only. The textbook talks about two other ways of displaying the nodes, but for our purposes, I think just displaying them in order is going to be good enough. Okay, so here in the private section of our code, let's create a function. Return type is void, and we'll call it display in order. And then here we'll pass the tree node. And since we're not going to be modifying the address in any way, we won't need a reference. We won't need to pass by reference, so we can just pass the pointer normally. So then our code will go here. Code goes here. And then since this is private, we'll need to create a public method for the user, and we'll call it show in order. And here we'll have we won't need any parameters. The only purpose of this function is to call the private function display in order, and then here we will pass by value the root. Okay, so for our private function, let's go ahead and set up our base case, because this will be a recursive function as well. So if tree is null, then we'll return, else we'll do something else here, which I'll talk about right now. Okay, so to display the values in the node in order, we're going to need to follow an algorithm, right? So that algorithm is, first we go left, then once we meet our base case, once the address is null, then we print the value, and then we go right. Okay, so let's see how this works. So we call display in order. We call it on the first address, which is going to be the first node, which is root. Then we check the base case. If it's not null, then we need to go to the left. So then we're going to call display in order on the left. Right, so here on the root node, the left is pointing to address 250, which is right here. So then we're going to need to call that, and we're going to need to hold on this function. So we're going to need to pause it. Okay, so the first function call was paused, which is indicated here by a little stop sign. And then this function called display in order on 250, which is right here. And the reason I paused it is eventually we need to go back, we need to backtrack and print its value and then go right. And then once all these three things have occurred, then we can remove this display in order 200 from the call stack. Right, but now we have a new display in order on 250. Then we need to check the base case. If it's not null, then we need to also go left. So then we'll need to pause this function call as well, and then call the new function. Okay, so then now that we displayed, we paused display in order on 250. Now we move to the left, and then we were on display in order 192, right? Because that's what was in the left. Now from here, we need to check the base case. If it's not null, then we need to call display in order from 192, but on address 000. Okay, so then now we pause display in order on 192, and then we call display in order on 000. But since this is null, that meets our base case, then this function will terminate and it needs to be removed from the call stack, and then we need to go back to display in order 192 and continue the algorithm. Okay, so then now we're back to display in order 192, which is right here. We already went left, so we already took care of step 1. Now we need to go to step 2 and we need to print the value. Okay, so then we print the value, and the value ends up here on the result. I put them here on the bottom, but you could think of this as the console window. So then we print out the B. So that's step 2. Now we need to do step 3 from here, where we move to the right. Okay, so then we pause the function here, and then we call display in order from using the right address, and it's 000, which when we call this, the base case is also null because there's nothing there. So then we can remove this call from the call stack. Okay, so then we're back on display order 192, and we already did all 3 steps. We went left, we printed the value, the B, and we went right, and there was nothing there. So then now this function can also be removed from the call stack. Okay, so now we're back at display in order 250, which is right here. We already went left. Now we need to print the value. So then the F will be printed to the screen. And as you can see here, now the F is printed on the screen. So we took care of step 2. Now we need to take care of step 3, and we need to go to the right. Okay, so then we pause display in order, and then we call display in order 000 for the right side. And since this is our base case, the address is null, then there's nothing to print, so we can remove this function call from the call stack. Okay, so then we return to display in order on 250 right here, and we already went left, we printed the F already, and then we went right, and there was nothing else. So now we can remove this function call from the stack. Okay, so now we're back at the beginning, and we need to finish the execution of display in order on the root on 200. We already went left, so we already took care of step 1. So now we need to take care of step 2, which is to print the value. Okay, so then step 2 occurred. Now we have the M. So far we have BFM. Now from display in order, we need to do the third part, which is go to the right. Okay, so then we pause from here. We call display in order on the right node, which the address is 325. So then from here, since the base case is not met, this address is not null. There's actually a node present. So then from here we need to start the algorithm again, because this is a new function call. So we need to go left. Okay, so from 325 I went left to 150, and then we check the base case because this is also a new function call. It's not null because there's a value, there's a node present. So then we need to also do step 1 here from this node, and that's go left. Okay, so then we pause this function call here for 150. We move to the left, we go to the address here 000, which meets our base case. So then we know we've reached the end. So we can go ahead and remove this function call from the call stack since it met the base case. Okay, so then now we resume the display in order. It already went left, so now step 2 is to print its value. Okay, so then that prints out the P. Now we can go to step 3, which is go right. Okay, so then we go right, same thing happens. There's nothing in there, it's null. So then we can remove this function call from the stack. Okay, and then for here, since we already went left, we printed the P already, and then we went right, there was nothing there, then this function finishes. That was it for that. So we can remove this one as well. Okay, so then we're back here at address 325 on this function call here. We already went left. Now the next thing for this function to do is to print its value. Okay, so then the R is now in the results. So then the next thing, it's already went left, it already printed its value. Now it needs to go right. It needs to go to 510. So it'll call that display in order function on this address. Okay, so then from display in order 510, the base case is not met. It's not null. So then it's going to need to go left and right. So first it'll start with left, then print its value, then go right. Okay, so then we pause the execution of that function, and then that way it can move to the left and display an order on address 000. But that meets the base case, so then this function call will be removed from the stack. Okay, so then we'll resume on 510, and the next thing is it already went left, there was nothing there, so then now it needs to print its value. That's the next step. Okay, so then once it prints its value, then it needs to execute step 3, which is go to the right. So then we'll pause display in order 510. Okay, so then display in order is called on the right node of 510, and that meets the base case. There's nothing there, there's nothing to print, so then we can remove that from the stack. So then that's removed. Display an order on 510, it already went left, it already printed its value, and it already went right, so that can go as well. And the same thing for R. For this 325, it already printed its value, it already went to the right, so then that one's gone as well. And then finally on the root node on display in order, that one already finished its call as well, so then that one's gone. And then now, so now you see that we have the B, F, M, P, and R, S, and they're in order, and that's how it was done, recursive. Okay, so once you understand what's going on, the code is pretty simple to write, and since it's recursive, a lot of things are going on that are hard to, I guess, visualize, right? But the code itself isn't too difficult to write down. So then what we're going to do is our algorithm. So first we need to go left, so display in order, and then we go tree left. Then step 2 was to print the value, so we'll do cout tree value. I'll put some sort of space. There you go. And then step 3 was to display in order, and we have to go right. And of course this here was our base case, right? Okay, so I think we have about everything we need, so that way we can actually test this out, see if it's working. Okay, so we already have this set up. Let's insert some other values here. So I guess I will insert from here. We'll insert insert F tree, insert B, here we'll insert R, tree, insert S, and then tree, insert P. And then finally, let's display all that. We put it in some weird order, but we'll go ahead and display it in order. See if everything is working okay. Oh, sorry. Show in order. Okay, so let's see what happens. Control F5. Oh, we broke it. Okay, so I figured out the problem. The most important step when defining a class is don't forget your constructor. Constructor goes in the public section of the class. So constructor. And then the constructor, we need to make sure that we initialize our root, initialize it to null. And with that, it should work. So Control F5. There you go. And it prints them out in order. All right, we inserted them in, however, they came in, right, BFMPRS, but they print out in order here. Okay, so in the next video, I'm going to show you how to actually use the search tree to actually search for a value, and how to remove nodes. But this video, I think, has gone on for about an hour, so I think I'll end it here. Okay, well, thank you very much for watching, and if you have any questions, of course, you can always email me. Thanks.